Okay, fantastic. Right. Okay, so these are some of the projects that we have done. So just now was in the US, then we have some in China, right? And these are in Dubai. So most of the, basically the ones that if you go to Dubai, you will look into some of these architectural buildings. So like the Burj Khalifa and the Grand Mosque of Abu Dhabi, right? So, and something quite interesting in Dubai, we have also worked together with the printing company. So we are doing 3D printing, right? So Dubai, they have their 3D printed offices, they have 3D printed laboratories and so on. So this MR Properties being one of the main developer there, they also decided that project, because at least we know that, you know, we are slowly moving forward so much, right? And in Malaysia, we also have inquiry so far for one project that is also looking into 3D printing. So initially, I always thought that 3D printing will probably come into Malaysia like what, 20, 30 years later and so on, right? But it is definitely coming sooner than I expected. So we have already seen at least one project having this inquiry coming in, right? Right, so closer to home, we supply to some of these projects in Singapore, like the Marina Bay Sands and Iron Orchard. And here in KL itself, we have supplied for the past 3 to 4 years. So these are some of the projects that we have done, right? So you may be quite familiar with some of these projects here, right? So why does all of this project look into Laticrete, right? It's because we provide what we call a system solution and also the warranties that come together with system solution, right? Because a lot of time, what we notice is when you put it into a BQ, things are separated into packages. You have waterproofing, you have adhesive, you have basically everything is separated up, right? Sorry, I just need to mute somebody. Okay. Right. So basically, system means from anything concrete up. Why is because every time we look at things, we look at separately. So what can we get at the most cost efficient at the, let's just say, waterproofing, then the most cost efficient at the adhesive and so on and so forth, right? But then after that, when you try to put them together, sometimes they may not be compatible, right? So for Laticrete, we like to look at it as a whole system rather than a separate entity. And when you have the whole system, right, we will actually minimize these things from happening. For example, you have efflorescence. These are all very common things that happens on site. When all these things happen, the next thing that will occur is who is going to bear for this, right? And then when you look into warranty claims, then everybody will be trying to point fingers at everybody because they will say that, you know, efflorescence is definitely not a tile issue. So is it now a grouting issue? Is it going to be a adhesive issue? Right? And then now if you have so many different brands in all the layers, then everyone will come together and say, you know, so because there's so many factors, right? So when you want to do warranty claims, it becomes something very complicated. And it may take a very long time also as they try to sort out who is going to be the one that, you know, to solve this issue. Whereas if you were to take a system approach, right? That means, as I say, if everything comes under one brand, then it's much easier to pinpoint who to look for when such a thing happens. So in Laticrete, other than following what the market provides, so the market provides what we say product warranty. They also provide joint warranty together with the applicators. For Laticrete, we provide one more warranty, which is what we call the system warranty, meaning anything from concrete up. If you use Laticrete, when anything like this happen, Laticrete will bear not just our product, we will also bear for the labor costs, we also will bear for the finishes costs, right? So of course there's some terms and conditions applying, but basically when you go for system approach, if there's any failure, just look for us, right? So that's how we look at things. So when we look at tiles and stone installation system, like for example, why does tile fails? Why do the tile pop up and so on? It could be a lot of reasons. It could be the tile itself. Maybe they have a lot of powder underneath. It could be the adhesive failure, right? It could also be the script failure. It could also be the waterproofing failure. Every single layer here, if they were to fail, it will means the tile will just come off, right? So that's why we always look at it as a system. Because every single layer matters. Because if one layer you don't, just a single layer, right, fail only, everything fails, right? So they actually come together, they work together. So ideally, we look at it as a whole rather than individual products, right? So for example, sometimes when this happens, when tiles come off, right, on site. So normally what will happen is we will have technical people to come on site, they will have to see and try to determine where the failure is. Did it fail at the waterproofing layer? Did it fail at the screed layer? Did it fail at which layer did it fail? So in this case, it fails at the screed layer. So you see the screed came off together with it, right? And it's very common, especially in Malaysia, to see screeds happening like this, whereby you have spider cracks everywhere, right? And a lot of time when this happens, most people will just say it's like that lah. Screed is supposed to be like that, right? Screed is supposed to have all these cracks. It's impossible to have crack-free screed, right? So because this is something that we are so used to, so we would think that this is normal, right? But you can actually reduce the cracks a lot, right, by actually using the right ratio. So normally in your BQ and your specs, you do specify very good ratio. But when it comes to site, right, when you transfer back to site, what they practice on site is very much different from what is written, right, on paper. Right, so normally on site mix, we have less cement content because they will put one bag of cement or one part of cement to 7 parts of sand, right, or sometimes even more than that, right? And it depends on how it's mixed on site, right? Whereas in Singapore, they prefer a pre-pack. That means it's already pre-packed, the ideal ratio already. So all they need to do is just to add water and mix it, right? So there's no way for the ratio to run. Whereas here, it depends on the worker. Some worker, their changkol is bigger, fuller, right? Some as they hold it, hoist it up is much less. So your ratio always runs. So certain areas, the ratio may be a certain ratio. Some, as you move along to a certain area, the ratio is different. So what happens is once it starts to cure, the evaporation rate is very different from one place to the other place, right? Because of the ratio differences. So as the evaporation is different, the rate of it is different, then the cracks also starts, the shrinkage cracks, right? So it depends. And sometimes, instead of using the mixer, this is very common. We built the volcano, the volcano method, right? So the volcano method of mixing, it depends on how good is the mixing, but generally, most of the time, you won't get until so homogeneous sort of mixing. So all of these things contributes to some of why our screed in Malaysia is so common to have all these cracks happening. And because of that, leakages is very common as well, right? So all of this, you can lower all of this from happening by using a pre-packed mortar, right? So that's one way to look at it. So next, we move on to waterproofing because it's very, very, like I said, every single layer matters, right? So sometimes, like this case, the tile came off. So when we look at it, everything is intact, but the waterproofing came off, right? Here, basically, we will know that it's the waterproofing layer. So basically, you go to site, we have to do some investigation. And then when we see, then we determine which layer failed. So in this case, we determine that, okay, waterproofing failed. So now, what causes the failure in waterproofing, right? So there's many factors. Sometimes the factor, it could be this, right? When you use cementitious waterproofing, it always comes in 2 parts. So 1 part liquid to 1 part of powder. But we can see that in this site, we have a lot of liquid left, the powder finish, right? So you will know that the ratio definitely have run already, right? Because the liquid is left over is so much, whereas the actual recommended dose is actually 1:1, right? So you know that the ratio has run, and therefore the performance also would have run, right? So that's one factor, right? Another factor could be that they only use a single coat, right? So that for what they have bought, it could cover a larger area, right? So you can lower down costing from there. So you end up using only a single layer. So the thickness we can tell because 2 coats, the thickness is about 1 mm, right? So from here, you could see that it's only 0.5, right? So yeah, so without having that 2 coats, you also do not get the kind of performance that we have already shown in our technical data sheet, right? So these are some of the factors. So one is probably the improper ratio. Second is probably they only did 1 coat, right? And this is very common. The third one is the sequence that we practice in Malaysia. The sequencing itself is also another issue. So here, normally let's say that this is the concrete here, right? So come to concrete, normally the next thing we do is we put waterproofing. So once we put waterproofing, then only we put our leveling mortar, right? Then only we put adhesive and our tiles, right? So this is the very, very common build-up in Malaysia. But if you have heard, some contractor may come to you and ask you, in shower area, is it possible? I just don't want to put the waterproofing, because when you put waterproofing, the failure chance is very much higher, right? So if I don't want to put waterproofing all the way up, right? So that is a very common question that comes, right? And why failure rate becomes higher is because of this. Your waterproofing layer, normally cementitious, is going to be choose for typical toilets, right? So cementitious, when they bond onto concrete, their bonding strength this is for my product, our bonding strength is only 0.9 Newton to concrete. The products in market is half of this. So we are talking about 0.5 Newtons, right? So then after that, you put your leveling bed, which have the tensile strength of 1 to 3 Newtons. So it's pulling very much harder than this. So this one, I bond to this at 0.9. The other brands in market is 0.5. And then you have a 1 to 3 Newton pulling at the 0.5. So that's why you can see there's a phenomenon called the reverse suction, whereby as it cures, it pulls. There's a reverse force that it pulls up. So what happens is over here, it starts to have a bit of hollowness, right? As certain areas start to come up. And this is just the design, the way that we put our sequencing, right? So that's why normally we try to recommend that you put the script first, the leveling mortar first, then only the waterproofing, your adhesive on top of the waterproofing, and then your finishes, right? So this method is practiced in basically overseas. It's just Malaysia that's practicing the other way around, right? So this method, you could see that suddenly, how come the waterproofing has already increased? Just now was 0.9. Is it a different waterproofing? It's actually, no, it's the same. You can see that here when we did the testing, our tensile strength is 1.7. That means it's almost 2 Newton, right? But that is testing onto mortar bed. But when we test onto concrete, because concrete, you have more oil and it's also more dense, right? Therefore, for it to have that kind of bonding is much less. So it's basically cut by half. So this is the same as the other brands. If you go to every different brands, you ask for their technical data sheet, it will be the same. The tensile strength will be much higher than the adhesion to concrete, right? So that's why this method, this sequence would be more ideal than the typical sequence that we go for, right? So it's even more imperative when you are doing it outdoors, right? So because outdoor, you are now subjected to heat, right? Constant heat, constant thermal fluctuation and so on, right? So it's even more, stressful for the products itself. So if you put the weaker bonding first, then this is what happened. They will come off, right? And this is another a reason why we would recommend that waterproofing come after leveling bed is because here, this is the leveling mortar, right? So why is because after that, it's easier for us to tuck into the piping. If we have done the other way around, the waterproofing is down here, right? So there's no way to tuck in to the piping. So you may have a gradient to the gradient to fall and so on, and to the piping, but let's just say there's some leakages here. So you will leak all the way in to this area if your waterproofing is at the bottom. So you leak all the way in and it gets stuck here because there is no way for it to go, right? So that is also something to look at. But as you do this build up, when it does leak inside, the waterproofing layer is there. So at least it goes all the way into the pipe, right? So this is typically on site. You will see this is how they do it. So the waterproofing is obviously underneath already. So underneath, then they did the mortar bed, and then they have the pipe, they cut it off, right? And then they leave it as that. So this is where the over time, right? There's movement and whatnot. So these differences as you lay it down and put your tiles on top already. And then over time, it starts to shrink, right? So when the mortar bed starts to shrink, your tile is not shrinking. So what makes up the difference here, right? Who is taking the stress here at the tip here, right? So that's why normally when you go and check at the projects, you will see the hollowness always happen at the corners of the tiles, right? You tap, how come it's always at the corner one, over time, right? So this is why here, the adhesive have to be the one compensating for the stress, right? So basically, that's why it tests so much onto the shear bond strength rather than tensile. Not so much on tensile, a lot on shear bond. Why? Because this difference here, your tiles adhesive can only absorb, it cannot absorb 2 Newton per square millimeter sort of difference for a very long time. Eventually, it will disintegrate. Right, so when it disintegrates, it will disintegrate until the area whereby is only 0.5 Newton shear stress. Then it will stay. So normally when you remove tile, you see, there's one circular area normally at the center only. The corner, empty one. How come? Right? It's because it disintegrated. Right? The stress is too high. Right? So if you use just normal adhesive for, let's just say if your tiles is quite big or an area whereby there's a lot of movements and so on, you see that the edges, as you go further away from the center, that means the larger your tile, right? As it goes further away from the center, the stress increase a lot because remember, the shrinkage is happening. So adhesive have to compensate for it, and therefore you will see there's very high stress here. It's okay for the first year maybe, but for the second year, you start seeing suddenly so many hollow happening because it has disintegrated, right? So that's where S1, S2, flexible adhesive is so important, or at least those adhesive that complies to a certain level of shear bond strength is so important because here basically it's the same size of tile, but you see the stress lowered by a lot because the adhesive is flexible. Why is the adhesive flexible? Because we add in polymers, right? We add in chemicals in, right? So of course, the more chemical we put in, the better the performance, right? But of course, this one you have to always check with your the supplier itself because some adhesive on paper looks like it's very high strength because of a lot of polymer, but the polymer may be sensitive to water. So please don't put it into the swimming pool and so on, right? So this one always refer back to the supplier because sometimes it may look good on paper, but it may not be so good when you put on under certain conditions, right? So these are the adhesive ranges that we have, right? So you can see C1 until C2TE, S1P1 and so on, right? So of course, normally on BQ, you expect C2TE, right? But notice that is where the gray area is. C2 means 1 Newton and above, right? 1 Newton and above can be 1.3, can be 1.4, can be 1.7, can be 2.8, right? It could be, a lot, right? So if you just spec C2TE, a lot of time when it comes to the contractor, they will go for the lowest end of C2TE, right? So if your tiles are of a certain size, let's just say if it's big size and so on, if you have 800 by 800 or 600 by 600, if you want to put onto the wall, then a low end of C2TE may not give you the kind of strength that you need, right? So that's why there's a difference here. So even if you were to just spec C2TE, it may not give you what you want, right? And you will see, what's the point of putting it in? You will still fail in the end, right? So the best way is to actually put the product name and you put that all equivalent, right? So that would be the best because the product itself will already show you what is the criteria that this product has, so that if they want to change, they have to match back the equivalent product, right? So that is the best way that I can think of that you can ensure a certain performance is met, right? Okay, so last but not least, of course, two components doesn't mean it's better than one, right? A lot of time, there's a little bit of misconception that two components always is better than one, right? But times have changed. Last time may be true, but now times have changed. Our single component is much, much better than our two components. But there are situations whereby we may want to use the two components. For example, if you're dealing with certain things that is very sensitive to water, right? Then we may want to use two components, because two components, this is latex, so there's no water at all. Whereas this one, you need water. So it depends. Certain time we may use two components, certain times we may use one, right? Okay. And of course, the next stress is expansion. That's why expansion joint is so important. If not, you will have all these things happening, right? So of course, I know expansion joints may look a bit ugly. We try not to put so much if we can, but it is very important to have expansion joints, and it's very important to have your towel gaps as well, right? So of course, ideally, we will always say 3 mm will be the most ideal. I know that there are some certain requirements that they say we want it at 2 mm, we want it at 1.5 mm. It can be done. It's just that you have to ensure that there's enough, perimeter gaps and so on, that there's sufficient expansion joints and so on. If not, you will have this thing happening, buckling in the middle, right? And this one is very dangerous one, because when it suddenly buckle, right, it's like an explosion one, it suddenly boom, like that. And it is not subtly come off, it just like that. So very, very dangerous, this type, okay? So movement joints is very important, right? So always remember expansion joint, movement joints, right? Over how many meters and so on, normally internally, we are talking column to column, or at least less than 10 meters, every 10 meters, less than every 10 meters. If you're looking at externally, you're looking at every less than 3 meters, or every 3 meters, you might want to have one, right? So perimeter joints, very important, right? Expansion joints, important, okay? So you can always fill it with silicone, or you can also fill it with the expansion joints itself. But in Laticrete, we provide the silicone. We don't provide the metal expansion joints, okay? So these are some of the areas that you can use on, right? Okay, and then the very, very last is basically grout. I'm not going to touch so much onto too many things about grout. I just want to touch on the common grout issue. I think this will be a very common issue you see on site, especially dealing with polished tiles, right? Normally the living room area. You see at the very sides here, the sides, there's a lot of etching happening, right? So then they will tell you that it's probably either the tile problem or is it the grout problem, right? So I would tell you that this issue is actually none of that problem, right? The issue is this: a lot of time when they lay the tiles, one day later they grout. After they grout, they cover it with a canvas sheet. So remember, everything is wet underneath. The adhesive is not fully cured yet. Your script is also not fully cured yet. Your grouting, you baru just apply the grout only. So what happened is, when you straight away put the canvas sheet on top, the air, the vapor has nowhere to go, right? There's no escape, right? So nowhere to go, they will find any weak point that's possible for them to go into. So tiles, they are very strong. Normally it's tested almost impervious when it's tested from the top. It's never tested from the sides, right? So that is the weak area of the tiles itself. So that's why when the air is trapped with nowhere to go, you will look into the sides. And therefore you have all these etching marks. It goes underneath the tiles. So this one you cannot clean one. So unfortunately, to resolve this, you have to remove the whole tiles and lay it back again. If not, you have to grind, repolish the whole thing, and then you have to put your nano coat again, which doesn't make sense. So generally, they will just rehack and put the new one in, right? But if you cover it again, you will have the same problem again. So the ideal is, this is all the testing that we have done, right? Together with the tile supplier itself. So we have done all this testing here, and basically, it's true, it's definitely the air that is trapped inside. So a lot of water vapor, and that causes the etching at the sides, right? So to avoid this from happening, we would highly recommend, right, to before putting the sheet, you at least let it cure for 3 days, right? Let the air, vapor and whatnot disperse first for at least 3 days. then only you cover it with the canvas. So of course, if they are rushing for jobs, the other trades want to come in, they want to put wires and so on. Ideally is you don't put the grouting first. That means after tiling, you put the sheet already. Then once you're done with every other trade, you come back and you do the grouting, right? So that's one way to minimize this. But if you find all of that is very hard to comply with, I would hire, the next best thing is to, instead of using cementitious grout, you can consider using either a PU grout or an epoxy grout, right? So now this type of grouts, you will definitely not have this problem, right? So these are some of the services that we have, right? So of course, products is one part of it, but Laticrete, we don't just emphasize on our product, we emphasize a lot on our after-sales service, right? We are a very technical-based company, right? So we emphasize a lot on our after-sales. So we have a technical team that goes to site. I know many other companies will tell you they do the same, right? But the frequency of it is different. So our team basically goes to site probably almost every week, sometimes twice a week, depending on the project and how important, how crucial a certain area is. So sometimes they go 2 to 3 times or so if it's too crucial, right? So this is what they do on site. They will actually guide them on how to use the products, right? So this is basically our PU grout. So it's ready to use, right? So basically you just open the lid, you can use already. This is something in Malaysia, we're the only one supplying this at the moment, right? So very easy, no way you can go wrong with this grout. Just open the lid and you can use straight away, no mixing required, right? And the performance is fantastic. Okay, so of course we will also have basically, they will help you check for the hollowness and so on, right? And guide the workers on how to use the product. So basically all of this is to minimize problem from happening, right? Because these are some of the things we caught on site, right? So they will use, it's very interesting, this way of applying the finishes itself, right? So this one is when you don't have the tools, they try to use the margin trowel and they do their own gigi lah, right? Or here whereby they actually try to, install onto a wet surface. This one is already leaking, so they try to install onto a wet surface. So all of these things, we try to capture it as and when it happened, and we try to at least to let the contractor knows about it, so we can try to minimize this from future problem from happening. Right? So that's all for our sharing. If there's any questions, I think I believe you all was asking questions, and my colleague, both Ifa and Daniel, has been answering.
Kenny got a lot of questions. I think maybe Kenny can raise up now lah.
Okay, that's great.
Yeah, actually I typed in my questions in the chat already, and then most of my question has been answered. Okay, thanks. Later I will send you my email so you can send me your estimate, ANSI.
Yes, because we have a document on the joint. So I think the time is up, so I don't want to share it here. I'll email over the control joint document, including the formulation of determine the joint width, then also the distance of the internal joint and external joint. I'll email over.
Okay,
I
think there's a question in the chat.
Yeah.
Gordon.
Yep. Yeah, Gordon have a very good question. The first question would be the bonding agent that you mix together with OPC, right? So why is it any difference from using conventional type of adhesive? That's a very, very good question. All this bonding agent, right, generally have very, very high tensile strength. So that's why when you stick the tiles, they'll tell you, "Whoa, this one very, very good." Because when we try to pull it, it's very, very hard to pull out, right? So they will tell you very, very, very good. But when you go too high in tensile strength, you will sacrifice on the flexibility. It's just the way it is. When you go too high strength, the flexibility goes down. So it's always inversely. Failure tends to is a higher